All right, let's continue with Chapter 5, Part 2, Writing Equations of Lines. X and Y, the intercepts. The x-intercept is the x-coordinate of the point where the graph crosses the x-axis, where y equals 0. The x-intercept is the x-coordinate of a point where the graph crosses the x-axis, where y is 0. You would see that as like 2, 0. That might be where it shows up. The y-intercept is the y-coordinate of a point where the graph crosses the y-axis, where x is 0. And you might see the coordinates as 0, -7, something like that. We're going to find the intercepts and then graph. So for each one of these, I'm ultimately trying to find, first of all, where x is 0 and where y is 0. So I'm going to move these around, the equation around a little bit so I can find this. Like for instance, I'm going to add or subtract 4x from both sides of the equation, so I end up with -7y equals -4x plus 28. I'm going to divide both sides by -7. I end up with y equals 4/7 x minus 4. So then I'm asking myself, if x is 0, y is going to be -4. I'm going to do the same thing, but I'm going to do it with the x-intercept. I'm going to solve for x. So I'm going to add 7y to both sides. I end up with 4x equals 7y plus 28. Divide both sides by 4. I end up with x equals 7/4 y plus 7. Now these slopes are a little bit crazy, but it doesn't matter because I'm ultimately looking for the x-intercept and the y-intercept. All right, so when y is 0 in this situation, I'm going to be left with x equaling 7. So I can use that to plot my points. So when x is 0, y is a -4. 1, 2, 3, 4. And then when x is 7, 1, 2, 3, 4, 5, 6, 7, y is 0. So I can use that to find my line. And there's my line. I'm going to go ahead and build out the next two the same way, finding the what y equals and finding what x equals. Let's go ahead and press pause. You work those out and let's see if we get the same thing. So I'll do number 2, show you the answer, and then we'll pause and do number 3. So go ahead and work on number 2 and then press play. All right, this is what I found out. My x-intercept being at -5, or my x-intercept being at -2, my y-intercept being at -5. All right, I'm going to go ahead and work on number 3, same format. I'm going to probably build it below here, though, where I can have a little bit of room. Go ahead and press pause, and then come on back. Let's see how we did. All right, this is what I found. I found out when x is 0, y is 4/3, and then when y is 0, x is -3. Isolating both the x and the y. I can use this method to just take any equation, isolate the two, find the two intercepts, and that allows me to plot. All right, let's keep an eye on direct variation. A direct variation is a function in the form of y equals kx, where k does not equal 0. The constant of variation is k. It's the coefficient of x. Coefficient telling us it's a multiplier of x. So that constant that we're looking for is k in this situation. An equation is a direct variation if it fulfills these two things. Its graph is a line that passes through 0, or the origin, or IGIN, or the equation can be written in this form. Now notice there's nothing attached to the end here, nothing's being added or subtracted. A direct variation is something that we would call it's proportional. It goes to the origin when graphed, and when you look at the equation, it does not have anything added on the end. It doesn't have a constant, but it does have, indeed, a coefficient, or a unit rate, or a rate of change. That's what k ends up being in all of these situations. Okay, so what actually is direct variation? In a direct variation, the values of the two variables change in the same manner. As one value increases, the other also increases. Or as one value decreases, the other decreases. They kind of work together as a relationship. Writing an equation given a point. So write an equation of the direct variation. So that tells us if I have a direct variation, we know that it's not going to have a constant. It's going to go through the origin. That includes this point. Well, we can go ahead and plug it in. We know what x is, and we know what y is, and we can just go ahead and plug it in. There's my y, there's my x. I can divide both sides by 4 to get my answer of k equals negative 3/4. Let's try it. It says y varies directly with k. Find the equation of the direct variation. So if we know this happens, that's nice. That means we can go ahead and use our y equals kx to solve this. So I know y is 16, x is 10. Divide both sides by 10. I can see that k equals 16 over 10, which can simplify down to 8/5. So my equation is y equals 8/5 x. There's my equation, knowing that there's no constant on the end. Let's try it again with this other one. Why don't you go ahead, press pause, you try it, and come back and see how we did together. Y is 4, x is 12, divide both sides by 12, k equals 4/12, or k equals 1/3. So my equation of my line is going to be 1/3 x. Write an equation of the line in slope-intercept form. So my slope-intercept form is y equals mx plus b. B is my y-intercept. M is my slope. Internet. Oh, looks like that says internet. Huh, that's kind of funny. So if I have my pieces, I can go y equals, I know my slope is 6x, and I know my y-intercept is -2. So there is my first equation in slope-intercept form. Now this one's a little bit different. I know the slope. I know that a point it goes through, but I need some other pieces of information. So I'm going to use this equation. There's my slope, y minus 4. Now notice I'm using a point that I know, and I'm going to simplify this out. Distribute that 6 to both sides, minus 24. Go ahead and add 8. End up with y equals, my slope is 6x, -24 plus 8 is a -16. There's my equation in slope-intercept form. Now when I go to my last one, this one again, I do not have my slope, so I need to find my slope. And I can do that by working my equation where I take y2 minus y1 over x2 minus x1. And just the difference of points here. That gets me 12 over -4, which is going to be -3. So now I know my slope, and I actually know one of the points. So I'm going to pick this one. So I can come back to my original method here of point slope form. So I know a point. I'm going to use 4 equals, I need my slope times x minus, I have the point. So point slope form, I use this when I know a point and I know my slope. Now I can simplify. Let me distribute this x to both sides. This is when students tend to run into errors because they lose track of the negatives in here. So please do not let that be you. Continue to simplify. Y equals negative 3x plus 10. There's my equation in slope-intercept form. Now we're going to write equation in standard form. Now standard form is that ax plus by equals c. And some people, when they're interacting with this as students, I find that you look at A, B, and C as important pieces of information. They're parts of our equation that we're using. So A and B are not telling us anything about the slope. They're not telling us about the y-intercept. They're part of the equation. So don't necessarily look for that coefficient to tell you something necessarily. Another point of detail that we need to keep track of this is the A. Okay, this particular coefficient, it must be a whole number. Okay, so when you finish it all up and you get in an ax plus by equals c format, you might possibly need to do some multiplying or dividing everything in the equation so that a can be a whole number. And because it's a whole number, it needs to be positive. So very often your a ends up being a fraction, or it ends up being a negative number. Then you have to do something to the entire equation to affect a, change a, so that it indeed is a whole number, which is a positive number. So I'm going to move this stuff over here because I need a little bit of space. Oh, that's fun. Hey, there we go. So I know my slope, I know point, so I'm going to use point slope form. Y equals negative 6 equals 1/2 my slope times x minus 2. So I get y plus 6 equals 1/2 x minus 1. Subtract 6 from both sides, so I end up with y equals 1/2 x minus 7. Now I want this in standard form, so I need to bring my x back over. So I'm going to subtract 1/2 x from both sides. So I end up with negative 1/2 x plus y equals a negative 7. Now remember, my coefficient of x needs to be a positive number, which it is negative, so I'm going to multiply it by a negative. It's half, so I got to get it to a whole number, so I'm going to multiply everything in here by 2, or actually negative 2. Make sure I distribute everything and keep track of the negatives. Negative 2 times negative 1/2 x is just going to give me x. Negative 2 times y is going to be negative 2y. And then negative 2 times negative 7 is going to be 14. There's my equation in standard form when given the slope of half and the line passing through 2, negative 6. All right, on this one, I would like you to try it. I got to find the slope first. So find the slope and then use one of the points. So go ahead and press pause. You try it out. All right, this is what I got so far. I found slope by finding the difference of the ratio, trying to find rise to run. So I found my slope being negative 3/5. Because I knew a point and I knew a slope, I used point slope form to get to my equation. I moved x and y over to the left side, so I have 3/5 x plus y equals a negative 2. And remember, I need to make sure my coefficient of x is a whole number, so I need to multiply everything by 5. So 5 times 3/5 x is going to give me 3x plus 5y equals negative 10, and that is indeed my standard form. Write an equation of a vertical line. Now, if at first this doesn't jump to you, just go ahead and do a little sketch on the side, kind of see what it looks like. I'm going to do for this one too, and go a vertical line, okay? So if I'm going to do a vertical line, what's that going to play out? Well, that's going to tell me that at x equals like 5. And there's my equation for that vertical line. Or maybe I've got one right here. And in that case, x might equal like negative 1. Same with the horizontal line. If I get a line going right here that's horizontal, I'm going to see that y equals maybe like 7. Or if I got a horizontal line right here, I might see that y equals like negative 1. Those are my equations of vertical and horizontal lines. We're going to click on the boxes to reveal the slope. So you want to keep an eye on what's happening. If you remember this, what happens with the parallel slope and what happens with the perpendicular slope. Okay, so if m, my slope is AB, my slope for a parallel slope will be the same, whereas for a perpendicular slope, it's going to be the opposite reciprocal of it. Okay. If my slope is -2, my parallel slope will be -2, but my perpendicular slope will be the opposite and the reciprocal of it. If my original slope is 2/3, my parallel one is going to be the same, a matching slope, but my perpendicular one will be the opposite. Will be the opposite and the reciprocal. You can see this, and it's reciprocal. If the slope is 0, parallel slope will indeed be 0. M is undefined in this situation. So what are we looking for? You're looking for a perpendicular slope. Now remember, so if M is 0, we're talking about horizontal line. And so if we're looking for something that is perpendicular to it, it's going to be this, creating a 90-degree angle. And when we see a horizontal line, the slope is undefined. It does not run. It rises, but it does not run. Write an equation in slope-intercept form of the line parallel to the given line that passes through the given point. Okay, so if I'm looking at parallel, I need to have the same slope. So I'm going to use this slope right here. But look at what I have here. I have a point and I have a slope. So I'm going to use point slope form. I get to use the slope as is. Okay. 2/3 x plus 4 minus 7 y equals 2/3 x. Uh-oh, I didn't distribute this. Dun, dun, dun. Back up the bus. That slope is still good, but I want some room. So let's back up the bus a little bit. Beep, beep, beep. This is not true. We need to do 2/3 of +4. Okay, so 2/3 of +4. I'm going to look at this as, it's going to help me look at this. I take the 4. That's going to be 8/3. Okay. Now I can subtract 7 from that. Okay, this is the part where I actually take the 7 and I look at the 7 as 21/3. I do that so it helps me kind of keep track of everything. So I'm left with y equals, my slope is still 2/3 x, but I have 8/3 and I'm taking away 21/3, so I'm left with 13/3. And you can simplify that and change that into a mixed number if you'd like, if it helps you figure things out. Okay, for number 7, let's go ahead and you press pause. I'll work this out and let's see how we did. All right, how'd you do? For number 7, what I end up doing is I end up moving numbers around just so I can start off with y. You don't have to do that, but I ultimately had to do everything I could to find the slope. Once I found it, I was able to use it. And once I had the slope and I had a point, I used point slope form in order to find my equation. Now we're going to write an equation that is perpendicular. So now for perpendicular, remember what we got to do is we got to take the slope that we have, and we need to find its opposite and its reciprocal. That's a fun way to spell reciprocal. All right, so this is not the slope we're going to use, but we're going to use the positive version of it, and we're going to use its reciprocal. And it goes to this point, so we know that I will be using point slope form. We're using that a lot today. My new slope times x minus 6, y plus plus 2 equals 1/3 x minus 2. I'm going to subtract 2 from both sides and I end up with y equals 1/3 x minus 4. So there is my equation of a line that will be perpendicular to the equation on y equals negative 3x plus 5. Okay, for number 17, I would like you to try it. Press pause, I'll play it out. Let's see how we do. So I took my equation, which indeed it started off in standard form, and I turned it into slope-intercept form so I could find the slope here. And then I used its opposite reciprocal. Once I had the slope I wanted and the point I had it, I was able to use point-slope form, or point-slope form, and work through that. I ended up down here. I took my subtracting 2 from both sides and I turned into negative 4/2, just so I keep track of my fractions. So right now, this is where I'm at. I am at negative 3/2 minus 4/2. So I'm going to minus 7/2. I can leave it like that if I want. And there's my equation. Y equals 3/4 x minus 7/2. All right, keep reviewing these concepts. You'll nail them real well. I'm going to go and dip my elbows in melted butter.